Welcome to this morning's panel discussion, the final frontier, automating the pick-and-place process. The desire to have fewer operators on the line is driving to increase efficiency and reliability is one of the big drivers for smart factory automation. And of course, the hardest part to automate in that process is the pick-and-place system. Today I've got a panel of experts, should I say, from each of the pick-and-place companies here to discuss some of the options that are available out there. To my extreme right we have Johnny Nichols from Hanwha.
Thank you, Trevor.
Johnny. Then we have Clemens Jargon from Mycronic. Welcome, Clemens. And of course we have Jeff Timms here from ASM Assembly Systems.
Thank you, Trevor.
Okay, so welcome, gentlemen. I'm going to jump right in with the first question, which relates to storage and where it makes sense to have storage within the system. You know, there are various different options. Are you going to have storage in one big humidity-controlled room, central in the factory somewhere? Do you have it in a storage tower at the end of each line? Or do you have it in a cart next to the pick-and-place machine? Where does it make sense? And what's the best solution? Let's start with you, Johnny, on the end.
Okay. So the answer to a question like that, in my opinion, is yes, yes, and yes. You have to have it in all locations, all right? And I think the importance of having it available in all locations is because there are different application environments that may justify having it more locally at the line or more in storage, depending on the type of parts that it is. It may need to be in a humidity-controlled area, right? And depending on what kind of volumes you're building, you may need to have larger volumes of parts in inventory. But I think the importance of that question, in my opinion, is how can you better utilize the intelligent systems that are available on machineries or offline for programming, where you can predict when you're going to have a part shortage and things like that. Mm-hmm. All of us here have intelligent systems where we can detect or determine, do we have the right part available to set up? Is it in the right location from speed? Does it have the right quantity of parts? And right. Quantity of parts is very important, although that may sound like the least important of all those three things. That's where you see inefficiencies occur on the line, because if you have to wait for a part to come out to the line, or if you have it already on the line, it's going to run out at some point. Yeah. So if you have a locally available cart that's next to the line, you can pull from there very, very quickly and easily. And it may not be the most automated system, but it works. And we see very high-profile companies today using just that kind of simplicity, but not discounting the other applications where you might need humidity-controlled storage and larger volume storage in towers and things like that are relative to multiple lines in the facility. So my opinion is you need all three of those things, and you have to be prepared to address all of them.
That's very interesting. Yeah. Would you agree with that?
Yeah, I think Johnny said it. I think there is no the best or the right position. We have customers who strongly believe in the near production tower placement, and we have other ones who say, I combine them and make a tower island a little bit far away, and other ones go for high volume storage and they work with AGVs. I think it's more about flexibility, and it's about modularity, because we know and we see that while customers grow, they continuously change their shop floor setup. And they need to make money out of their investment. And when I make systems modular and flexible, then I can do the right investment for them, and then they can decide what position and what setup is the right one for the right time of their factory setup.
Right, right. Does it also matter what kind of pick-and-place assembly system you're using as well, and how you're feeding the components or feeder banks to the line?
Yeah, I think it does, and I have to agree with what Johnny has said as well. All three modes of storage are viable. But I think one of the keys to being successful and profitable is the integration with the equipment and the integration with the planning for your production.
Right.
And so it's very process driven. What type of storage you use, where you use it, where you deploy it, is very process oriented, very process based. As far as the moisture sensitive devices and things like this, for example, if they're sitting on the floor too long, do you really want your machine to turn on, or do you want that machine to lock it out if it's exceeded its time limit, right? That kind of thing. So I would say all three types of these are very important. I agree with you, Trev. The types of feeding in the machines, the type of feeder exchange in the machine I think what you need to be very careful of in any kind of manufacturing in SMT today is that you don't just move the bottleneck from the machine area into the setup area, or from the setup area into the kitting area. It's important to address this as a holistic process, so that you really take the work effort and the streamline the process from beginning to end. It's not just in one place or the other.
Right.
And it has to be completely integrated with the equipment. The equipment needs to know what's there. The equipment needs to be triggering what is pulled out to the floor. And again, all three types of storage are very viable. Yes.
I mean, currently the area that's most automated is from the storage towers to the kitting area. People are using AGVs to do that type of thing. But I mean, you know, do you think that's the most important part at the moment, or what about how do we automate it getting from the kitting area?
I think that's a couple. If I can jump in on that one, there's a couple areas that need to be addressed on that. First of all, is it important to automate the kitting area? Yes, but it's also important to automate from the kitting area to the machine. And so things like self-loading feeders and self-exchanging feeder tables, and operators that can be directed to where they're needed, when they're needed, so that you're not adding additional manpower for no reason on the line. All that stuff is very, very key. And again, it comes back to how is your process designed, and making sure that you understand the implications of every downstream process on the upstream process.
Right. Would you?
That's crystal clear, and I think that's an important question. Our customers, they want to, and we have to help them to automate the entire process, from job planning to feeder loading to reel handling. The entire material flow up to the machine has to be organized. But it is a little bit depending on which type of business you run. I think when you're in the very high flex area, in the very low mix area, then for sure you can do family kitting, you can fully automate this. But as more and more you go into high mix, you need to individually handle your reel, and then you can less and less automate and be more flexible. And what I'm a bit missing right now, I think we have done already a good job in the software integration. We have done a good job in storing material, but we are not yet there in the entire robotics surrounding. I think the robotics, which we definitely need to further optimize the process, need to be more smarter, more intelligent, more ease of use, and more flexible. Just robotics is not enough. We need cobot solutions here, and this is where I think we are yet waiting in the industry to get more support from these experts to get further automation support for our customers.
Right. It's an interesting area altogether. I mean, because I agree, you need a bit further automation, but I think the reels, the tape and reel systems, quite frankly, that we're using at the moment are very dated. There's a lot of waste there. I think the way that the component handling needs to be changed in some ways. And I know some people have come out with, in fact, you've come out with one option using vibrating trays, but I mean, there needs to be more creativity, I think, in that area. What's your view on it, Johnny?
That's a very challenging area, and I agree with you. I think it is very dated technology, and I think we all wish there was a do-all, end-all solution to eliminate that variability, because with tape and reel, robotics, they like very repeatable process, right?
Yeah.
Every reel is a little bit different, and the older the reel, the more worn out that reel is, the more hard it is, the more difficult it is for a piece of automation to address that and set it up in a way that's very, very time efficient. So, alternate feeding technologies, bulk feeding technology is certainly an area where I think needs more exploration. We've come and gone a little bit with that, and I think I would personally like to see more development going along those lines to see what we can do to maybe eliminate some of the reel process and the variability that is associated with that.
Right. Okay. Well, as you say, pick and place systems like the robotic, and they like repeatable instructions. But I mean, maybe we can learn something from the inspection and AOI side, where they're starting now to individually measure components and things like that, and bring some of that into the pick and place side, because components vary. Some components vary, and that causes issues for pick and place. So.
Well, I think that's a key aspect of it, Trevor. But the equipment today already does that, and does it quite nicely. So if something is out of the
Polarity or
or spec, either gets corrected on the fly or it gets rejected if it's really out of bounds. But I think in agreement with my colleagues here, the component manufacturers need to be a big part of the solution, because repeatability and in the feeding process is absolutely paramount, and the more variation you have at the input side of the machine, the more difficulty you're going to have on the placement side of the machine.
Right.
If you can't pick it up, you can't place it.
Right.
So
why is there so much variation in component sizes? I mean, I don't know enough about this. I mean, maybe you do know more than me, but is there not standardization in the semiconductor world? To say that the devices need to be a certain size within a certain tolerance.
Within electrical tolerance is different than size tolerance.
Yes,
and
that's what I mean.
And thickness, width, length, all of these factors, all these form factors come into play, and you'll have some companies that'll manufacture a part that's very rectangular, very square, very sharp corners. Another one will have one that looks very trapezoidal, so they're all over the map, and so feeding mechanisms become very challenging, and this is why tape and reel still has a role and will have a role for quite a long time, unfortunately.
But that's a function of the trade association to bring in standardization to stop all of this variation.
Yeah, I think we are, on one hand, we are known as a very innovative industry. I think we are challenging ourselves. We want to have light-off factories at best already tomorrow. On the other hand, we are really depending on extremely outdated technologies. Yeah, so far it's tapes and reels. I think nobody yet can imagine how to do it different. But on the other hand, it is for sure. It is the entire environment, the entire ecosystem of handling components, which is really made to handling reels and tapes. Yeah. I think we need to change over time, and I think we need to think a bit more disruptive, but it will take incremental time and step by step to change because of the ecosystems being made around tapes and reels. Yeah? But on the other hand, should we let tapes and reels determining how we run placement? Sometimes we have to change, but it will be difficult.
Yes, yeah, you're absolutely right. And if you think about the ecosystem of feeding an SMT assembly line, it's very involved. It's very, very involved. And if you look at the next generation, all the next generations of equipment, everything is being designed going forward with an eye towards robotic component replenishment.
Right.
So there's a lot of innovation yet to come on this subject.
Right.
But it's going to really require the involvement of the component suppliers themselves.
I agree. And it's interesting. When you see some of the prototype machines that have come out recently. I think some of these robotic solutions are they going to expand the footprint of the placement system? When you try to roboticize it and automate it.
I would say not if it's done right.
Okay. All right.
I'll leave it there.
Yeah, interesting. Okay. Okay, so the Industry 4.0 is obviously driving the need for post-placement AOI. Do you think that's a function that should really be brought inside the pick and place machine rather than being something that's a separate box after the pick and place? Johnny?
That's an interesting question. and there is a large group of people that would like to see that happen. But then you have to be realistic, right? These are pick and place machines that are designed to do things well that are within the realm of a pick and place machine. And you have to ask yourself, are you willing to sacrifice best in class pick and place and because you want to marry in a one-size-fits-all solution that can do the AOI and automatically feed back. And the trade-off with that is performance, right? And North America is all about high mix, lower volume. But make no mistake, people need to build as fast as possible. Time is money, no matter what your production environment is. And I think when you look at the prospect of integrating AOI into pick and place, I can say this, it's already there to some degree with all of our machines, right? And the conduit is there. But when you look at the illumination systems that you need, relative to competitive AOIs that are discrete systems that are absolutely best in class and far superior to any kind of AOI machine that you could integrate into the head of a pick and place machine, I think it's a stretch to expect makers of pick and place to integrate a formal AOI machine that can compete on a level with the discrete systems that are out there.
Really?
Okay?
Okay, that's interesting. You know, most people when they're thinking about putting inspection in the line, you know, the SPI is a no-brainer. Post reflow AOI is where they put it most. They're very reluctant quite often to put it after the pick and place system. But frankly, the earlier you catch the defect, you know, in the process, the more money you're going to save. I mean, so there is a requirement, a need for it, and especially, you know, if you're going to optimize your process, then there's a definite need for it. What's your view on it?
I think the good reason why we invested in VI technologies to make it a part of the Mycronic family, because we knew that these AOI capabilities have to be an intrinsic part of the entire pick and place process. But the AOI is really determined by high performance cameras, by high performance illumination, by high performance optics, and bringing all this into a pick and place machine. I'm not sure if I think then the machine really would be capable enough. We should have in mind, I think, when the process capability is at a value of 1, the verification capability has to be at 10 times higher. Yeah? And if we do really want to have the pick and place machine doing the AOI, or not having this as an explicit high performance AOI process after pick and place, I think this is a better solution because the process parameters and verification parameters are not the same.
Right.
I think that when you look at the SMT's assembly process, there's a place for it in the equipment, but you're not going to replace the end-of-line AOI. For example, in the screen printer, statistically, it's pretty easy to determine that you might most probably have your errors on one specific component. It'd be nice to have a camera that can check those, you know. So if you can check that, and then go back and redispense a missing dot before it leaves the printer, now you're talking about something of real value.
Yeah.
Right. Once you get into the machine, for example, if you have a $50,000 ASIC component that you're trying to place for the military, you may want to look at all of those placement locations underneath that ASIC to make sure nothing else is there, so you're not covering up another component.
Right.
Because those parts are not reworkable generally.
That's true.
And you know, by the other area that's really benefits from this kind of a process are components that end up underneath shields. So you have a machine that's placing some components, and then you put a shield down. You want to make sure before it leaves those machines that everything is right underneath the shield, because you can't see it with the end of line AOI.
Yeah.
So it's a whole series of process steps.
I think that's a good analogy what you said. So we have, for example, also in the jet printer a 2D inspection solution, which can do somehow inspection, but when we really want to go for true first pass yield, we have the SPI behind the jet printer, and that makes a repair file, and that can repair then any board. I think here's also, I think you have certain limitations what you can integrate, and the high performance you have to have as a separate machine.
Right.
I'm
I mean,
a strong believer in
that setup you're referring to, Clemens, basically then guarantees 100% paste volume when it leaves the printer. What we're looking at here, by integrating some AOI maybe into the pick and place, is that you've got 100% placement when it leaves the pick and place system, and that's, I think, where we need to try and go towards. You know, I take your point, Johnny, that it's difficult to try and integrate that in there, but it's just
there's already levels of AOI in pick and place.
Yes.
All right, and you have to have a look down camera to be able to see the things you want to see. And
right.
Jeff brought up some very specific applications where that is absolutely of value, hands down. I think everybody would like to have that ability, and I think the makers of the equipment are being pushed to extend the capability of the look-down camera systems, be it a fiducial camera system, whatever it is. It could be a specialized system that is more AOI-oriented so that you're not sacrificing too much speed. But at the end of the day, it's always about the quality. It is about your efficiency, but it's always about the quality. And when you look at AOI, it's a form of test and fault coverage on a board,
Yeah.
right? Printing, certainly. There's been many studies done, right? Most defects that are seen on a line come from the printing process. If you can make sure that's dialed in, you've got that corrected on the front end before it even gets to the pick and place, that's good. But then if you've got the concern about artifacts being on a board before you place a shield or an expensive IC, absolutely check that. If I could do that, and if I was running a machine or a shop, I would embrace that technology. I think that's a very valuable, a value-added feature benefit that all placement makers should be considering integrating into their system. So I think
Yeah.
that's a great idea.
Yeah, I agree. Fascinating debate. I'm going to have one very quick last question. I just want a yes or no answer. Are you looking towards, is it in your roadmap to have a fully automated pick and place system in the future?
A fully automated, meaning no
Yeah.
people on the line?
Correct.
Sure, we all are. But the variables, the supply chain variables on the front end, there is so much that has to be done far outside the production line. I would say it's easy to set up a robotic system to repeatably make a printed circuit board. But the variables that you have to take into account, the feeding of parts, whether it's tape, tube, tray, loose parts, things like that, the board fabrication process, how good is that? You know, we're being pushed to place smaller, right? 0201 metric parts. You can't have a lot of variation in the board fab. But the problem is you have multiple suppliers of board fabrication. You have a lot here, a lot there, and there's different tolerances within each one of those. So to pull off what you're talking about is doable. It's expensive. But again, I think there's a lot of peripheral support and agreement and participation support that has to be done outside the line.
Right. Now, you make some great points there, Johnny. I mean, I think one of the things that components needs to go into place to be able to make all this happen is a much better understanding of the material science and being able to control that, because as you rightly say, there's a lot of variation in boards, they stretch,
goodness,
they warp, etc., etc. Clemens.
I think for maybe low volume and no changeover, you might be able to do it soon. As more high mix you go, it might be more difficult. You could do, but I'm not sure if customers would like to pay the money for keeping it reliable, sustainable, and high quality. That might not be around the corner, but for sure we're all working on to get there, step by step by step.
Okay.
Yeah, I from the standpoint of ASM, certainly we're moving in that direction as quickly as we can. There are a lot of variables to address. We've taken dramatic steps in the last 6 years to reduce the number of operators, maintenance technicians, planners, kitting personnel, et cetera.
Yeah.
And it's gone from a factor of 10 to 2 in those areas. So it's been remarkable already what has been reduced from a manpower standpoint. Ultimately, the goal is to have as few non-value-adding functions on the line as possible.
Right. Fascinating debate, guys. Thank you very much for your input today. And thanks for joining us. Johnny Nichols from Hanwha, Clemens Jargon from Mycronic, and of course Jeff Timms from ASM.
Thank you very much,
Thank
Trevor.
you. And thank you for joining us today.